Not difficult. Okay. So I'm trying to find this piece here, right? Well, that piece does not make a right triangle, does it? So I know I can't use that piece. But I do know that I have a right triangle here. And I know an angle, and I know a side.
Wait, Mr. Sell.
Yes?
Do you must have a right angle triangle?
In order to do any of these, we must have a right triangle. Yes, this only works for right triangles. Okay, so then that was the opposite. This is the adjacent. So we use TOA to be able to find the length of this side, which was 28.87, something like that. All right. Then, okay, now I have enough information to do this triangle because I have an angle and I have one side. So I can find this side, which is the adjacent side. It's a three-step process here. So first I had to find the missing side from the small triangle. Then I'm going to find the missing side from the larger triangle, which again we said was, what, 35.67?
Yeah.
Okay? And since I'm only looking for part of this side, I know the 21, so I'm just going to subtract out the part I know, and subtracting out the part you know will give you the part you don't know. Okay? All right. So we use TOA on both of those, so the tangent on both of those. Okay? All right. Now there's a second part you said. Calculate the length of the longer support cable CD. Okay. Well, CD is this cable here, yes? Okay. So we're using this big triangle here. We know two sides. We know this side and we know this side. I would probably use this side simply because the other one, we've used it, we've rounded and rounded again. So this first one was only rounded once, so it's going to be a lot more accurate than the other one. But they're going to have taken that into consideration as well when they do it. So we're looking for this angle, this side, which is the hypotenuse. So we have OA, so that's so, right? So the sine, oops, I'm sorry, you don't use the E in the abbreviation, of 38 degrees is equal to the opposite over the hypotenuse, and the opposite was 27.87 rounded.
Wait, what are we trying to find?
We're trying to find the hypotenuse of this long piece.
Wait, how do we do Pythagoras though?
No, well, you could, no, because, yes, if you had the two sides, you could use Pythagoras on this. Trig is easy.
We got 35.
For the other side.
The other side.
Right, for this side. But this side stayed the same. We found this side. So you could use Pythagoras if you wanted to. I think the trig is easier, but it doesn't matter. Okay? So, if you wanted to use this measurement, what did we find out for that total measurement, guys?
35.6. Yeah.
There you go. I could use this side and find the hypotenuse that way as well. 27.87 squared plus 35.67 quantity squared, or 35.67 equals c squared, and then solve it using that as well, the same, okay? Either one of those. Now, the only thing about using this is that using this number that we've rounded several times. So your decimal is probably going to be a little off, but again, you should get close enough. So using this puppy, what did you work these?
2049.09
Equals c squared.
I think so.
Then take the square root of both sides to get your c. And what's that going to give us?
45.27.
There you go. Now let's do it the other way over here. We're going to multiply by x to eliminate the fractions.
So you also get 45.27.
Then we're going to divide both sides by the sine of 38 degrees. The divided way over there gives me x equals, what'd you get, Sora? The same exact thing?
Yeah.
And it should be the same thing because we're measuring the same piece.
This is too scary.
Okay?
Is this part 2 that was just
Yeah, that's part 2.
Okay.
Okay? So, you may have to use pieces of another triangle to be able to then find the pieces from the triangle, the triangle that you're looking for. Okay? So for today, what we're going to do is we're going to look at the inverse trig functions. I'll just go ahead and write it down so then we'll talk a little bit about what it means.
Wait, is this going to come into test as well?
Yes, it is. Remember that when we're solving an equation, we need to be able to do the opposite, right? So what we're going to learn about today is we're going to learn about the opposites of the trig functions. Every trig function has an opposite. And we need the opposites so that we can eliminate the trig functions from an equation. Okay? So, if you look at your calculator, right above the sign, you're going to have another button that has sine -1. Do you see it?
Yeah.
Okay. Right above cosine, what do you have? Cosine -1. And right above tangent, you have tan -1. These are the inverse or opposite functions or ratios. In other words, these functions will eliminate these functions, right? Just like multiply by 2, if I divided that by 2, those two things would eliminate each other. They're opposite operations, right? So we can use the inverse functions to eliminate the trig functions. And we need to talk about why we would ever do that and when. And here's why. The slowest writers ever. It's all right. Okay. Right? Well, I'll just put it at the bottom here. Okay. The why we're doing this, okay, is because we use the inverse functions. Nope, sorry. Use the inverse functions when we are looking for an angle. So last time we used the angle to help us find the sides. This time we're going to use the sides to find the angle. Right? And because you can do that, because we know we can use the angle on one side to find the other side, by default, you must be able to use the two sides to therefore find the angle between them. Okay? So, but in order to do that, we have to use the inverse functions. So if I want to eliminate sine, I'm just going to use sine to the -1. The inverse. Okay? If I want to eliminate cosine, I'll use cosine to the -1. The inverse. Okay? And we'll see, we'll show how that looks. So it's usually, you have to do shift and then cosine, sine, tangent. All right?
What was the stuff? What was it?
So we calculated this angle as 30 degrees.
Listen, do you give us permission to jump out the window?
All right, so here we have an angle. I know this 8. What is the 8? The hypotenuse. I know this 5. What is the 5? The adjacent. I don't know this thing. What is that thing? The angle, theta. But if I'm using, which trig function uses A and H? Ka. So that's the cosine. Not yet. Of what angle? Theta equals the A over H. So 5 over what? 8. No, because this is cosine. We're not going to switch them around. That's going to mess with you. All right, so here we go. Now, I've got cosine of theta. I need to get that theta by itself. In other words, I need to get rid of cosine. What thing eliminates cosine? Cosine -1, the inverse. But if I take the inverse of one side, what? I have to take the inverse of the other side. Over here, the inverse and the cosine simply eliminate each other. What is that going to leave me with on that side? Theta. And then it's to your calculator. You'll put in cosine -1 of 5 over 8 and round it to 2 decimal places, which gives me...
51.32.
And, units, degrees. Well, because that's just showing you what those were. Shouldn't have even shown you that. Don't worry about that. Okay? You start with the right way around, then you use the inverse to eliminate it. Okay. Don't worry about the wrong way around ones. Okay? Now, for this one, they're writing. Have you take it? What did we do to figure this out? Which one did we use? Yeah, cosine -1, the inverse cosine of 5 over 8. Okay? Because we were trying to get rid of ka, I mean. Okay? Here we go. 10, 16 theta. So, what is 10? Opposite. Yeah, what is 16? Hypotenuse. And what is it we're looking for? Yeah, so we're using to find the angle. So is sine of what angle? Theta equals 10 over 16. Now I need to undo the sine. How do you undo a sine? Take the inverse sine of which thing? Both sides. Over here, they simply eliminate each other, leaving you your theta. And over here, you're going to do sine -1 of 10 over 16. Rounded to 2 decimal places, someone?
38.68.
I'm sorry, what is this one? 38.68 degrees. Don't forget your degrees. Boom. How easy is that?
Really?
All you have to do is plug it into your calculator. Okay? All right. Yes. Let's look at an application, guys. All right. An LED grow lamp is mounted 1.8 meters from the ground. Ladies, shh. Okay. So if the projection has a width of 2.6 meters on the ground, calculate the angle H. So this angle. Now, what do we know if we have this line and this line? That's making a what kind of thing? A right angle, right? And we can make a triangle from that by putting this side here, but that's not going to help us any. Which side will help us, though? Well, the bottom one's good because that's part of the triangle H. So what we're looking for here is we're looking for this triangle that's being made, right? With that angle. So we have one measurement, but I don't have 2 measurements. And remember, I can't do anything without 2 measurements. Well, do you see another right triangle up there? Yeah, but splitting it in half again is not going to help us because I don't have the measurements. I don't have any measurements for those missing halves. So, but wait, what?
If you have, scroll down.
I know the bottom.
And then you go to the middle thing, it's this one.
So, oh, wait a minute. Do I know that from that edge? Okay, then we'll do it your way. Hold on.
Do it your way. Fine.
Do they give you this kind of grief all the time? Yes. So we know the height all the way from there to there. So you can make two triangles out of it.
And then you find the angle of one triangle and then
Or alternately, you can use this outside triangle to do it either way, right? And then find this measurement. But either way, so we'll show it both ways. So if you split the triangle in half and make two triangles out of it, I wish I could make this small fit. Okay? We know that the height from the bottom to the top is 1.8 meters. So we're just going to use half of that. So 2.6 is going to give you 1.3. So, and then this height is 1.8. Here's our angle. So that's the what? Opposite. This one is the what? Adjacent.
why don't you just pick bright green?
Because it's cute.
Okay.
Thank you.
1.4.
So this is the opposite. This is the adjacent. So that's TOA. Right? So tangent of our unknown angle, so we'll call it theta, is opposite 1.3 over adjacent 1.8. 8, yeah. Sorry, that's my handwriting. All right. How do I undo tangent?
-1.
The
You know TOA is oatmeal?
inverse tangent. But whatever you do to one side, you do the same to the other. Over here, these just eliminate each other, leaving me theta. And then tangent of -1 of 1.3 divided by 1.8 gives me what rounded to two decimal places? Someone?
5.84.
I'm sorry, what is it?
35.84.
35.84, right? But what have I done to this triangle?
Split it in half.
So that means I only have how much of the angle?
Half of it.
So I simply multiply it by 2, gives me what?
71.68.
And units, degrees.
I'm not writing this down, but I mean.
Okay, it's being recorded.
Is it
Good job.
usually less than, like,
Absolutely.